this is the motor circuit. This is the motor circuit. This is not a shortcut. Look, after here, the terminal block goes to the miniature circuit breaker and then to another terminal block. Then it goes to the page. Now let's focus together. This is the cross reference they left. We will need it again later. It tells you exactly where it's going. 15 QM, 16 F1 and 15 16 B1. And this is called plus M and minus M. First, plus M and minus M, because this is a DC circuit, so it's plus and minus. This is a motor circuit, so it's called M and minus M. As you will see here, for example, an indication circuit is called plus and minus IND, the abbreviation for indication. Or plus and minus T, which is trip. And you have trip 2 and trip 1, or plus and minus C, which is the closing circuit. Or plus and minus R, which is the relaying circuit. So this is the positive and this is the previous. Okay, go to page 15, F1 and B1. So what should I do? We understood that the first number is the page number and the second number consists of two parts. The first part is a letter, which is the row number, and the next is a number, which is the column number. Okay, so now I'm standing on which page here? On page 14. Where do I want to go? Page 15. So I go to which page? Here it is, page 15. So what do you want from page 15? You want F1 and B1, right? Isn't that what they told you here? Here it is, F1 and B1, right? Great. Okay, come on, here it is, Engineer Sushad. This is page 15. Where is F, Engineer Sushad? Come on, here it is. Here is F, it will go here like this, all right? And here is B, so it will go down here like this. So the thing he told me about falls in the intersection area shown here indeed. So minus M was indeed going to page 15, which is F1, and the other one was going to whom? To B. Here is B. All right, and here is 1. So the intersection between them here indeed found plus M. So here is minus M, and here is what? And here is plus M. So indeed it led me to the cross reference or the grid. I have to know which page it is going to and where it is located on which page. So when I came here, I found it telling me that this place is coming to you from page 14, F3. 14 F3. If you came here and took a step back to get here to page 14 F3, right? Here's the F going this way. And here's the 3 coming down from above like this. And here's the F, the 2 intersect here. So you actually find your plus M and minus M. So you will also find the same thing coming from F3. So this is necessary for cross-referencing so that you don't come here and say, student, where is this going? And end up flipping through all the pages to see where it's going. No, it tells you which page it's going to, which page number exactly. So you entered here to the plus M and to what? To the minus M. All right, great. So you entered here and entered there. Now, why did it go? It's going to power the VCB spring charging motor. VCB stands for vacuum circuit breaker. The term vacuum circuit breaker means that the type of circuit breaker or the area where the spark is broken or interrupted is a vacuum. What does this mean, Engineer Rashad? If you look here in the video where we were explaining the switch gear yesterday, and it showed you the circuit breaker here like this, and it showed you a breaker and did an X-ray on it here, engineer. Here is the circuit breaker. We agreed that it connects the supply from the bus bar to the feeder or vice versa. Now, the part where the spark is extinguished could be SF6 gas. Of course, this is the method used to classify circuit breakers. In the previous course on medium voltage circuit breakers, which you attended with us, there are 3 ways to classify circuit breakers, either by voltage level, whether it's low, medium, or high, or by the arc quenching medium, which is the medium for extinguishing the spark, such as air, air blast, oil, SF6, or vacuum, or by its mechanism, which could be a spring type mechanism, hydraulic type mechanism, or pneumatic type mechanism. Nice. So here I'm talking about the PCB, meaning this part where the poles of the breaker move to open and close. It moves in a vacuum, meaning it's something evacuated. All right, engineers, very good. So here you have, engineer, what's going to happen is that you brought the supply here and now you want it to go to the motor. Well, the motor, in all the circuits you will see in front of you, the thing you want to operate will have a negative connection and is waiting for the positive to reach it through your control circuits. It has a negative connection and is just waiting for the positive to operate. So your motor now has a negative connection from below and is waiting for a positive from above. As it goes down, 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 it hits something called LS cam LS2. Well, before we hit something, I see Engineer Rashad that everything drawn here is normal except for some things. I find that they are drawn inside what? Inside a dotted square like this with continuous lines like this. And some of them have lines that are a long line followed by 2 dots, a long line, 2 dots, and so on. What's the difference between this and that and the things that are drawn normally without any lines? Well, look, engineer, you are sitting inside the switchgear cell, or you have a switchgear cell. Great. Now, all this drawing is implemented where? It's implemented in the upper part of the switch, right? Of the switchgear, correct? Great. Okay. Anything outside this upper area in the low voltage switchgear or low voltage compartment must be drawn with a dotted square around it. If it's a dotted square, like you see here, it means it's something located inside your cell, something located inside your cell. Is that clear? Good. And of course, something located inside the cell, but not inside it, it is within the electrical compartment. This means that this thing is inside the cell itself and is, of course, inside your electrical compartment. Is that clear? Okay. And if something looks like this, with 2 dashes like this, it means it is coming from another cell entirely, unrelated to my cell and not connected to it at all. All right, very good. Now, if it is a line, and a dot line, and a dot line, and a dot, and so on, it means the same thing. This also indicates it is coming from something inside, also within the same cell. Very good. So the appearance in front of me means it is coming from something inside my own cell. Indeed, inside my own cell. And this thing is this Kabi cut always creates the power of the Kabi cut that is written here. This means, engineer, with low voltage, meaning engineer Rashad. Our breaker, guys, as you can see here, when you place the breaker in its position, here it is, here it is. The electrical cut reached here. This electrical cut was outside a while ago, and now you have placed it inside the cell. You want to start closing the breaker and opening it, right? Well, imagine this breaker has a closing circuit and an opening circuit and so on. So you want to give it a close, you want to give it an open, and open what you want to give it. How does the breaker go in and out? Well, it has wires. These wires, my friend, must be through a plug. Why? To make it easy for you to remove the breaker or insert it again. Because if the breaker looks like this and its wires are fixed, you would have to sit and disconnect the wires to remove the breaker. Right or wrong? And of course, that's very dangerous. First, it's a mistake. Second, you might reconnect the wires incorrectly. With too much fiddling and fitting, you could damage the terminal block or the socket. You might accidentally cut wires, which can cause a lot of problems. So what happens? Anything that goes into the circuit breaker comes out here, all through this plug. This plug has many terminals. And on the other side, you have the cell itself. The cell itself in this part, this is the male and this is the female. Okay, this is the male and this is the female. We can call this a plug and we can call this a switch. All right, very good. So when you start connecting, here is the plug. So you connect a specific wire and a specific terminal to a specific terminal here. This wire is connected to a specific terminal here and so on. All right, so here it's the same thing. When you come to connect the plug, you'll find that the terminal coming from the terminal plug called X51 is connected to your female at a specific terminal. When you connect the plug, you'll find that the terminal of the plug called A1 is the same terminal that will connect to the same wire in your female. All right, very good. So LVB means low voltage plug. Why low voltage plug? Why voltage block? Why does it have a voltage block? Why low voltage block, my dear engineer? Because it sends you a set of wires used in control circuits. It wants to tell you that this is not the power of the breaker, but rather the control circuits of the breaker. So they are low voltage circuits, all right? Great. So who is LS2 then, my dear engineer Rashad? LS2, my dear engineer, you will go to the end of your drawing. When you go to the end of your drawing, my dear engineer, you will always find a diagram in the switch gear. You will find this diagram, my dear engineer, which draws for you, as you can see, the circuit breaker with all the circuits inside it. All the circuits inside it, all right? And you have all these terminals. All these terminals are the low voltage plug terminals, meaning all these terminals are connected to your male plug. All right? Great. Okay. I will go to the part that concerns me, which is the terminal in the plug named A1, and it was named A2 here. There was the motor, and before it, there is something called LS2. I don't know what LS2 is, so I go down here to see everything. If you look at LS2, it will tell me what it is. It's a motor stopping, meaning something that stops the motor. Closing spring, a charging indication. Yes, it means the spring is charged. George, an indication. Yes, it means that it is charged. The spring is charged. So what will it stop? The motor. This means that it should supply DC to the motor if the spring is not charged, and disconnect the DC from the motor if the spring is, well, if the spring is charged. All right, let's not forget. Very good. Great. Okay. So we haven't forgotten anything. This is your plug, and it's drawn for you down here. The plug consists of rows, as you can see, with letters A, B, C, D, and columns with numbers. Therefore, it's named A1, A2, A3, A4, and so on. B1, B2, B3, B4, and so on. Or it can have numbers. Like you see 42, 43, as he wants to put any numbers as he wishes. You have no problems at all. All right, so this is the shape of the plug. If you look at the teeth of the plug, this is what its shape will be. And these are the internal circuits. I just took this circuit and I will go back again to see the closed circuit and then go back again to see the tripping circuit and so on. All right? Very good. All right, Engineer Rashad. So now I understand that LS2 is essentially a limit switch inside the electrical component itself. And it is used as a motor stopping mechanism. So naturally, as long as the motor spring is not charged, this contact will be closed, allowing the positive to connect from above. And since the negative is already connected from below, the motor will have both positive and negative, causing it to start turning to charge the spring. All right, great. So this is our motor circuit. Now, after this, what else do we have? There's something else that's a bit strange. What's strange is that in the same circuit, in parallel, it goes here to a circuit breaker, relay. This is how it looks in the schematic now. If I'm not sure, I can go to the page and it will tell me that a square like this means this and that. All right, great. So this thing is here, like this. Check this out. It's here like this, okay? Where is it, engineer? So this is connected to positive and negative, so it's always working. Did I benefit from this, Engineer Rashad? No. Engineers, this is your XOR function. Remember, I explained the XOR to you, and it consists of a file and a set of contexts you have, right? Am I wrong? Nice. So in the normal situation now, when a supply comes here or a supply to this circuit, this coil is always working, so it closes its contacts, right? Or its contacts with me, whether they are all or what, they are all now change their position. If it becomes what? It becomes nice. I told him nice. He said to me, okay, simply like this in the way you see it. So what will happen? What will happen to you? When the supply is cut off for you, meaning Engineer Rashad, the supply is cut off for me. For example, maybe the source as a fuse has blown, maybe someone opened the link of the terminal block, maybe a wire from here got disconnected or cut, maybe there's any problem in the DC circuit as positive and negative, your circuit has encountered a problem. Immediately, this coil loses its supply, so it starts changing its normal positions and it begins to give you the ground, telling you there's a problem in the circuit, a problem in the DC circuit. In this case, engineers, what do we call this? Its function is called a DC supervisor. This means monitoring the circuit, specifically the design circuit. Focus on my words, monitoring the positive and negative only. What does only mean? When we move on to another circuit, you'll understand what only means. This also means that if you have a cut in this wire, it won't inform you. It assumes that this wire is coming here like this. And from the same terminal block, it exits here like this and continues like this. You might ask, how do you know? I'll tell you, this is a black point, meaning it wants to tell you that it's coming like this and exiting like this. Therefore, if the incoming is cut or the incoming is cut, it means the DC was cut off from reaching the DC supervision relay, which gives you what? It gives you an addition. But after this part, if this is cut or the motor burns out, it doesn't see you. It looks at the positive and negative paths from below, ensuring what the history is at your end. That the circuit is intact, which is a disaster if you don't pay attention. All right, let's come to this disaster. And this is our motor circuit.